Welcome, Andy. As part of our collaboration, TWI are using Hamamatsu laser welding systems. Can you explain why you selected these lasers for your research?
So at TWI we've been looking at laser welding of polymers for well over 30 years, and throughout that time we've gained a lot of expertise and experience in using different welding systems. And what we tend to look for now in collaborations with different suppliers are lasers that not only give a consistent output, and Hamamatsu technology goes up to 200 watts of average power, which is good for most applications. But the Hamamatsu system also offers a top hat beam profile, which gives a more even energy distribution across the processing area, good for welding. But it also allows and offers a temperature monitoring capability which hasn't previously been available before.
You mentioned temperature monitoring. Why is this important?
So temperature monitoring in polymer welding has actually been present in industry for some time now, but not in the way that gives you a good amount of information on what's happening at the actual weld interface. The Hamamatsu technology with the two-color temperature monitoring approach allows fine detail about what's happening at the actual weld interface in terms of the temperature that's actually occurring there. So what that allows us to do now is to use temperature as the parameter that we set when we're doing our welding trials. So whereas before we might be setting power, speed and clamping pressure to give different conditions with the weld, we can now actually set the temperature which we either ramp up to, we hold, or we ramp down from to give us additional options or to give us additional control over the weld and inherently its weld strength.
So with this new technology, what applications or areas of research do you think will most benefit from the technology?
So at TWI we already work in a number of different industries across different applications. Key ones here, especially for this Hamamatsu capability here, is the medical sector first and foremost, whether it's flat cassettes or even intricate parts where you really have to have fine control over what the temperature is at the weld interface, so you're not either degrading the part for future service or you're having not enough energy at the interface to create an inefficient weld. But there are other industries as well, such as the automotive sector, where you're welding front or rear light clusters, cockpit packaging, central console, anywhere you've got polymer around the interior. The aerospace industry, and particularly with the aerospace industry, you can tend to have welds where you don't have traditionally easy to weld polymers with a laser, so where you might have optically clear components, for example in a window. So what that actually offers up in terms of the Hamamatsu offering is to combine the two-color temperature monitoring method with our clear weld infrared absorbing technology, so that we can actually ramp up the temperature of the weld to exactly where the clear weld die begins to turn transparent and absorbs the infrared to create the heat at the interface. But it also allows us fine control over the weld temperature.
How do you see this affecting the markets in plastics welding in the future?
So because we already work in a lot of applications already at TWI, any new technologies that we evaluate here tend to get an independent evaluation by us at TWI, so that tends to help processes or products to get through to market where they're adopted by either integrators or other people in the supply chain. So as I mentioned previously, with the medical sector, the automotive sector, aerospace, and even other sectors such as the textiles and fabrics industry, there may be certain processes within those industries already where maybe lasers not already used. They may be using ultrasonic welding or hot plate welding or other welding techniques such as that. This might give them that additional option to use laser welding because it gives them that additional control over the process.
What benefits can members get from this collaboration?
So at TWI we perform work anywhere from the design review stage of a process all the way up to failure investigation, where something's actually failed in service. At TWI, we prefer to get involved with the member as early as possible, because that helps us to offer expertise in terms of designing the joint as well as developing the laser welding process. So with the Hamamatsu technology, we can now offer our members influence and guidance in that stage, but then also to move on to feasibility studies, proof of concept trials, and that allows a risk-free approach for the member, because they can evaluate the technology here at TWI, and if it looks like something that they want to greenlight and adopt later, they can move forward to scaling up or factory acceptance tests, or if it doesn't look like a technology that they want to adopt, it allows them to stop there without any further commercial or technical risk.
Thanks very much, Andy.
Pan 5.